Welcome to qnawire.
Hello friends, here it is given. There is a 3-slider rod, each of mass m and length l. So m is mass of each slider and 2a is the length of each. It is suspended by the wire from the centroid G. It is hit at B in the negative x direction, due to which there is a impulse I am marking with blue color. This is the impulse along negative x-axis. We have to calculate velocity of center of mass G and angular acceleration of assembly. Let us see here. First, you can write the moment of inertia of the composition. So that can be written as, already we have calculated in the previous question. I am writing it directly. It will be 8 by 3 ma square along y-axis. 8 by 3 ma square easily you may compute, and already we have done in previous chapter and previous problem also. I Z 2 by 3 ma square I x y I by z I z x is 0. Now the only impulse is f delta t along negative x-axis. So impulse is given minus f delta t I cap. So from impulse momentum equation we can write f delta t I cap to be mvx I cap plus mvy cap mbz k cap. So from here you will find velocity along x direction is minus f delta t upon m. Along y direction it is 0, and along z direction it is also 0. So velocity of center of mass we can write minus f delta t by m I cap. This is the answer of A part. Now we will solve for B. Moment of momentum. The moment of impulse is equal to angular momentum. So this concept we have to apply along centroid. So you will write a j minus ak cross r cross p is the angular momentum, and change in momentum is the impulse. So it could be written as hx I cap plus h by j cap plus hz k cap. Solving the left hand side, you may write af delta t k cap plus af delta t j cap. So hx I cap plus hy cap plus hz k cap. So angular momentum along x direction is 0. So Ix omega x is 0, that is angular velocity about x direction is 0. angular momentum along y direction is AF delta t, that is I by omega y. So angular velocity along y-axis is AF delta t upon Iy. This value you know, substituting, so you will get AF delta t upon 8 ma square by 3. So velocity along y direction you will get 3f delta t upon 8 ma. Similarly, along z direction, Iz omega z. So from here omega z will be Hz upon Iz. Hz is AF delta t. Iz is 2 by 3 ma square. So from here angular velocity along z direction 3f delta t divided by 2ma. So we can write angular velocity is 0 I cap plus 3f delta t upon 8 ma j cap plus 3f delta t upon 2 ma k cap, or you may write it to be 3f upon, just a moment, 3f delta t upon 8 ma you may take common. So this could be written as j cap plus 4k cap. That's all for it. Thanks for watching it.